Scientists have just invented a new type of robot that might save your life. The new robot is inspired by an unusual animal, the caterpillar, and can crawl through extremely small gaps. This is not some theoretically proposed object, but a real robot that has been tested in the lab. But why should you care about this robot? Well, one intended use of this robot is in search and rescue missions. Imagine you are unfortunate enough to be in an earthquake, and you are stuck under tons of rubble. Crushed. And slowly suffocating. This robot might be the reason that rescuers find you. So, let's discuss how it works. When you think about it, the way caterpillars move is rather unique. Snakes use their muscles to undulate their body to convert lateral movement into forward motion, while worms simultaneously relax their longitudinal muscles and contract circular muscles, lengthening their body and pushing it forward. Despite having similar tubular body shapes, caterpillars move in a very different way. They use the local curvature of their body to maneuver themselves. How their bodies bend is different between when they move forward and when they move backwards. If we can mimic this bending, then we could have robots that move like caterpillars. But while mimicking this with hard materials is possible, it is costly and lacks any real application. But making a soft robot that can move like this is another question. There are real applications for such a robot. To build something like this, we need a material that can contract like a muscle on command. Many materials do have this to varying degrees, but here the scientists have used a material that contracts significantly when heated, called a liquid crystal elastomer. Heating this material will cause it to contract by up to 40%, which is extremely large, and importantly, is completely reversible upon cooling. But to make this material useful, the scientists had to come up with a method of locally heating so they could control where the material contracts. Ultimately, any usable device would need to be controllable via standard electrical means, but this material requires heat to move. Devices called Peltiers do take electrical current and convert it into heating or cooling, but they are often cumbersome. Instead, the scientists used intrinsic heating from the current flow itself, Joule heating. If a wire has resistance, then the current that flows through it produces heat, as the thermal power equals the current squared times the resistance. This is why old light globes glow. To control the robot, they just had to combine these two ideas. They placed a layer down of the liquid crystal elastomer, and on top of it placed wires that they could heat. By heating different sections, they were able to get this little robot to pull itself forward and to push itself backwards. Heating large sections would result in reverse locomotion, while only heating a small section would result in forward motion. Ultimately, the heating translates to a curvature of the robot's body, thus mimicking the original inspiration of the caterpillar. But what are the applications of such a device? At the moment, not a lot, because it is connected to tiny electrical leads. But in the future, a new robust, compact design will open up many options. In the lab, scientists were already able to demonstrate that they could get this robot under a box to the other side. And this is where we might see some applications in the future. Soft robots like this don't require a lot of space to move. They are flexible, compact, and potentially robust to harsh environments. If this robot can be improved to exhibit all of these traits, then using it for search and rescue in fallen buildings may become a reality. This isn't the only recent development in robot technology. Scientists recently made liquid metal robots that have a wealth of applications. Check out this video to find out more about these miniature liquid robots.